So in the last video, we looked at how degrees match up with radians, and we looked at one very special triangle with a 45-degree angle here. Now there's one more special triangle that is of some serious interest, and that is this one. This special triangle here, the 30, 60, 90 special triangle, it actually creates two different sets of degrees. So the first one we're going to look at is the 30 degree. Before, when I did 45 degrees, I took this pi over 2 and I split it in half, right? And that's how I got 45 degrees, because I took 90 degrees and I split that in half. Now what we're going to do is we're going to split it into thirds. All right. So if I take 90 degrees and I split that into thirds, what do I get? I get 30 degrees, that looks pretty good. So I'm going to say 30 degrees. 30 degrees is also known as pi over 6. And why is that? Like, why did it shouldn't it have been pi over 3? You know what I mean? Let's look at this really quick. If I take this 30 degrees and I have 30 and then I have 60, I'm trying really hard to make these equal, but these three pi pieces should be equal. All right, so we have 30 and then we have 60 degrees is like, and then we're gonna have 90 degrees up here, right? And that's where our right angle comes from, okay? And then I'm just going to do the same thing over here. I'm going to split this into thirds as well, if I can. It's not perfect, but that's fine. So each one of these is 30 degrees, right? This is 30, then this is 30, then this is 30, 30, 30, and 30. Let's figure this out. If I split pi into this many pieces, how many pieces do I have? 1, 2, 3, 4, 5, 6. And that's why this is pi over 6. All right. So this one's going to be 1 pi over 6. This one's going to be 2 pi over 6. This one's going to be 3 pi over 6, which should just be half pi again, right? This one's going to be 4 pi over 6. Maybe I should write it. No, I'm going to write it here. This one's going to be 5 pi over 6. And then this down here would be 6 pi over 6. All right, it's also known as just pi. Okay, so when I look at my 30 degree here, and I want to figure out from this point here, how far over did I go on the x-axis and how far up did I go on the y-axis? And I want to label that here. We learned before that to figure out how far we went in the x direction on a unit circle, that one is going to be cosine of theta. And then we figured out to find how far up we are in the y direction, that is going to be sine theta. So let's do that. Cosine theta is adjacent over hypotenuse. So cosine of pi over 6 is going to get us how far we have traveled in the x direction. So let's look at our special triangle and go back to geometry for a little bit of help to find out exactly this distance. This then is our y direction, right? Or this equals whatever y is, and then here this whole distance is going to be our this is also a little confusing, so I'm going to, because root of 3x does not equal x, right? So I'm going to change my x's here to stars. If this distance is star, then the hypotenuse will be 2 stars. Okay. So now here we have our x direction. Now we can use this to figure out what x is. Now remember, my radius here is just 1, right? That hasn't changed. So 2 star really equals 1. So star equals 1/2. So my x here is going to really be the square root of 3 times 1/2. This is also known as, well, half of root 3 is square root 3 over 2. That's usually what we call it. I've taken the cosine of 30 degrees, so my x and y coordinates, remember this always comes in the form x comma y, right? That is going to be, for my x value, is going to be square root 3 over 2. Now let's find the y value. The y value is going to be the sine of, the sine function is the opposite over hypotenuse. So recall, opposite is what we're going for, right? Is like the direction in my in the y direction. And then the hypotenuse still is just 1. So y over 1 is just y. So if I take the sine of this, I'm going to get the y coordinate. And the y coordinate is equal to half of the hypotenuse, right? Because 2 star equals 1, solve for star, divide by 2, and that is what that side equals, which is just 1/2. So my y coordinate is just 1/2. And this is absolutely amazing. We can go all the way around the circle and we can find all the coordinates of these, right? And the coordinates, like where they're going to, where this little point is going to land on the unit circle, is just the cosine and the sine. Like this is so big. This is huge, absolutely huge. So let's continue to go around slicing this thing. So it turns out that when you have double 30, right, you're at 60 degrees, which is 2 pi over 6. I'm going to rewrite this. And those are my last two those are the biggest ones, right? You're going to have pi over 6, 2 pi over 6, and that pi over 4 that we did in the last video. You're going to get a blank canvas, which basically has those 3 angles, and of course our points on the x and y axis, right? Basically have those 3 angles repeated all the way around the triangle. And what I'm going to ask you to do is I'm going to ask you to find all the coordinates of each one of those points. All right, so let's look at 2 pi over 6, also known as 60 degrees, as well as, instead of just 2 pi over 6, 2 pi over 6 is also known as pi over 3, because I can reduce that fraction. Right? So again, we're going to look at this triangle. I'm going to drop this down. And I'm going to change color here. I don't know how well you can see this. But now we're going to do pi over 3. And here is my triangle for pi over 3. Pi over 3 is really just 60 degrees, or double pi over 6. And in order to find my coordinates always come in x comma y. Another way to think about that, it's the same thing as cosine theta comma sine theta. Amazing. So that's what we're going to do. We're going to do cosine theta to find the x value and sine theta to find the y value. So cosine of pi over 3 is going to give me my coordinate in the x direction. Now I'm going to change this. I'm going to rewrite this triangle so that way I am looking at 60 degrees with my 90-degree angle down here. All right, so here's my new triangle, right? Or the same triangle rewritten. And I want to figure out what I'm looking at for this distance for my x direction. If I look at the hypotenuse is just my radius, which just equals 1 still. So I just need to figure out what star equals. Well, if I just divide both sides by 2, star is 1/2. And then I want to do the sine of pi over 3. The sine is going to give me how my distance in my y direction up and down. And so here, this is my distance in my y direction. And so this is just root 3 times 1/2, also known as root 3 over 2. And this should be really familiar because notice I have 1/2 and root 3 over 2. Same thing here, I have 1/2 and root 3 over 2, but now instead of them being y and x, they have swapped to x and y. And that makes sense, right? If I just moved this triangle and just kind of, I just went more and like rotated it down here, then if I was halfway on the y-axis, now I should be halfway on the x-axis. And this is exactly what those trig tables were looking at, what the ancient Sumerians were looking at with those trig tables on that really awesome tablet that they found, right? When I rotate this around, how does that change my triangle? And so these two triangles are going to reflect all the way around, right? And we're just going to outline our pi over 6 in green. I think you'll be able to see that on the screen. So there's my pi over 6. And so when I come over to the other side, when I reflect over to the other side, my drawing is horrible. You can see how much higher my 5 pi over 6 is than this one. But these two are supposed to reflect. And so now that you already know the coordinates of this, which is root 3 over 2 and 1 over 2, those are going to reflect over here, except now I'm going to have this going in the negative direction, right? Then when I come down and I reflect it down, at this point here, my coordinates are still going to be the same as that, except I'm going to have them in the negative y direction, right? I'm going to have root 3 over 2 and negative 1/2. And then similarly over here, I'm going to have those same coordinates, except now both my x and my y are going to be negative, okay? And make sure as you're going around the circle, make sure that you count 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, and all the way around here, and you should get this point and label that point as to how many pi's over 6 that is. You're going to do the same thing for pi over 3. Now pi over 3 just happens to be 2 pi over 6, right? So you can think about it in terms of pi over 6, or you can count by pi over 3s. And you're going to get, if I come up here and I go 1 pi over 3, 2 pi over 3 should be here, because if I reflect that over there, and I'm just going to write in 2 pi over 3. And then 3 pi over 3, can you see where that's going to land? If I go 1 pi over 3, 2 pi over 3, 3 pi over 3 should land right here because 3 pi over 3 is just pi, right? So now I'm going to have 4 pi over 3. And I want you to label this as 4 pi over 3 and label the coordinates. 5 pi, oh, whoops, I was going to make that mistake. 4 pi over 3, 5 pi over 3, and 6 pi over 3 should be the same as 2 pi.